Hello, everybody. This is Nick Totero, Professor of Information Technologies and Computer Science, Lakeland Community College. All right. In the first part of this video series, we talked about the overall concepts of inheritance. And let's recap that really quickly. Inheritance provides us a way to create subclasses from parent classes, what I call parent-child relationship. So a subclass or a child class can acquire information or stuff from the parent class. This reduces redundancy. We don't like having redundant code within our system. It also cleans up how we can build classes and objects. In this video, we're going to apply it using Python. So let's go up to my screen. Let's take a look at my Visio and then let's Visio document and then take a look at how we do it in Python. Again, we're going to break this up into three parts. The first part is just two simple classes that kind of look the same, potentially could be inheritance, but not really. The second one is a pretty good example of how inheritance can reduce redundancy. And the third one, we get into really some sophisticated approaches. So let's go up to my screen. All right, first example. The difference between a character and a animal, they may look the same. They have the same four basic attributes. They have some, but not all of the secondary attributes. But like a character, if I make a change to one of the basic attributes in a character, it would change the secondary attribute. Not the case with an animal. So looking at my screen, this is my little diagram, Visio diagram of the character class. If I go to animal, this is the animal class. Again, notice that the attributes and the methods may look the same, but they are different. That's why we can't really use a child-parent relationship, because for a character, it doesn't change the secondary attributes the way that an animal does. So if I go to PyCharm, recap on PyCharm. PyCharm is a really nice IDE for the Python environment. It's what I use when I'm developing Python code. Don't worry about the IDE or the Python or anything like that. It's just a different IDE. But if you get more and more interested in Python and you want a really strong working environment in Python, I strongly encourage you to at least explore PyCharm. So anyways, we have our little GURPS environment. We have our main.py. We have our character library, our animal library, our vehicle library, and the equipment library. So under main, first thing we're going to do is we're just going to create a character and we're going to create an animal. But let's take a look at character. You saw this in other videos. You saw this in class demonstrations. Nothing really fancy here. Let me scroll this down a little bit. But notice now up here in character, right here where we define the initial class. It says class, uppercase C, that's a convention in Python. Notice that the open and close paren are empty. This tells us that this class is the top level class, or more importantly, this class is not derived from another class. This is not a child of another class. If I go to animal, I see the same thing. I see the class here, uppercase A, convention, and again, you will notice right here that the open and closed parens do not have anything in it. So again, this tells me this class, and remember what a class is, it's the cookie cutter that allows us to create objects. This class is not derived from a parent class. If I go to main and I run main, let's see, we have the created character called Robert Canyu. Here's Robert Canyu's particular information, points, secondary attribute. You saw that in other videos. If I look at the animal that I created an animal called large guard dog from the animal class. It's a large guard dog. It's named Yogi. It has all its characteristics. It has some traits. It has some skills. That's what this list down here is. These are traits. These are skills. And when I run it, it prints out the OG is a large guard dog having the following characteristics. We've seen this before. This is just two objects being created from two separate classes. So now let's take a look. Let me get this. Now let's take a look. We're going to highlight this out or comment it out. Let's take a look at vehicle. And vehicle, I'm going to create three different vehicles. I'm going to create a roadster, I'm going to create a canoe, and I'm going to create a biplane. A roadster is a ground vehicle, a canoe is a watercraft, and a biplane is an aircraft. Let's take a look at the vehicle library. And if I scroll all the way up, you will notice that we have the parent class. Now, if I go back to my Visio and I look at vehicle, here is my parent class. All right, so here's the parent class. Every vehicle that is going to be, or actually every subclass of vehicle is going to have all these characteristics to them. So if I go back to PyCharm now, you will notice that class vehicle, uppercase V, open and closed paren, that just means that this is the parent, or more importantly, this class is not derived from another class. Okay, so nothing in an open and closed paren class just means that that class was not derived from another class. Here are my attributes. These are what I would be calling. Here's my constructor method. Here's my setters, my getters, my doers. And if I scroll, all these are setters, getters, doers. A lot of them here because it's the parent class and it actually has a lot of attributes. You will notice that the parent class of vehicle has a print general vehicle method, and it has a print general vehicle attribute method that would allow us to print the general information. Let's take a look at the first, go back to here, let's take a look at the first child class, which is the ground vehicle. Now, the interesting thing about the ground vehicle is it only has what the parent has. It doesn't have any additional attributes. And you can see that it doesn't have any additional attributes, but it still has its own constructor. It still has its own method. So if I go back to PyCharm and I finally get to here, here's our first one. Class, ground vehicle. You notice the uppercase. But more importantly, notice the open paren. Open paren, the parent class name. This tells Python that this class, the ground vehicle class, is derived from the parent class vehicle. Then it goes through the same constructor method. You will notice has all the attributes over here, and then you have this right here, this super constructor method. And what super constructor, and what that means is these attributes are coming from the parent, or we can use the methods of the parents. It is derived from the parents. So here is the two big differences when we have a child class or a subclass. One, you have the open paren with the parent, you have the open paren with the parent class in there, parent class, and then you have the standard init that's going to construct it, but then you're going to have a super init. And this says this constructor is going to be based upon the construction that we saw with the parent class. But it's fairly boring. Let's be honest, it's a ground vehicle is just a vehicle. So I intentionally made a ground vehicle because I wanted to create a method associated with a ground vehicle. So I created a simple method called print ground vehicle. I still have that ground vehicle, and all the other children have access to the parents' methods. All right, so very small class, but it still has everything associated with the parent vehicle. Let's take a look at watercraft. Now, watercraft's a little different because watercraft has an additional attribute. Remember, watercraft has the attribute of draft. Draft just means how high or low the boat rides in the water. Again, if we look right here, We have the class watercraft, uppercase. You will notice the open paren vehicle. This means that this class is being derived or is a child class of vehicle. You will notice now, there's the constructor. Now, right here at the very end is the draft attribute. So it looks almost identical, but it has that extra attribute. Now this little super comes into play. And what the super says is get all these attributes from the parent. So very similar to what we saw here in ground, but ground was the same. You know, the constructor and what it was getting from the parent class were the same. In here, watercraft, construct it and get these attributes or build these attributes based upon the parent. And you will notice that it has its own methods. It has a set draft method, it has a get draft method, and it has its own print watercraft methods. It can still access the parents. And if you notice, like right here in some of this print, this one right here, this line right here, it said self-print general vehicle attribute. What that line says is acquire or get the method print general vehicle attribute. Then print the watercraft vehicle attributes. So the watercraft vehicle attribute just kind of adds one more print there. So do everything from the parent print, which we saw before, but add the draft information. You notice that we don't have redundancy here. I'm not copying and pasting the methods from the parents. I'm saying I can use the parents, and I am using the parents. That's right there. But then I still need to add something, right? And I need to add the draft. Let's take a look at aircraft. Aircraft is going to be the same thing. We have the class statement. Aircraft vehicle is derived from vehicle, the open paren vehicle. So aircraft vehicle is derived from vehicle. We have the standard constructor. And notice over here, we have that last attribute called stall. Notice here, we say get everything, all this other stuff from the parent. And then we have a stall here. We have a set stall, we have a get stall, and we have print aircraft vehicle. So if I look at this line right here, get this line. Look at this line right here. Try it again, Nick. It says use the print general vehicle attribute method from the parent, but then print the aircraft information. Don't worry about this down here. That's that classic if underscore underscore name underscore. So let's go back to main now. And in main, we have, we're going to create a roadster. We're going to provide it all these arguments to the attributes. We're going to create a watercraft. We're going to provide these arguments plus the draft. And then aircraft, we're going to create all these arguments and we're going to include the stall. Notice how we've eliminated the redundancy. If we had to create each of those classes individually, they would be identical. 90% of it would be identical. Let's run it. All right. So we have the roadster. Roadster stops at location down here. We have canoe. Canoe has location. Canoe has a draft. And then we have a biplane, has location, and it has a stall value. All right, let's take a hard look at equipment. So let me highlight these out or comment them out. And let's take a look at equipment. All right. Let's start with some simple equipment. All right. We're going to create a 30-foot piece of rope. We're going to create a small shield. We're going to create some cloth armor. Then we're going to create some, what do you call it? We're going to create some weapons. Let's go back to Visio and let's see what's going on. And then we're going to actually look at the code. So inside Visio, we have the parent class, which is equipment. Then we have the children classes of weapon, shield, and armor. Notice now in my Visio that I have the child, open paren, and then the parent. And then underneath weapon, now look here, some slight differences here. We have the melee weapon, which is derived from weapon. So melee weapon is derived from weapon, weapon is derived from equipment. And the same thing with the range weapon. With the range weapon, it's derived from its parent, weapon, and its parent is being derived from equipment. So let's take a look at the code. So let's go to equipment. And let's go to the very top of equipment. And you can see we have the top level class. We have the parent or the grandparent, now what we can call it. Open paren, close paren, nothing in it, because that's telling us it's not derived from anything. It's not a child of anything. It has all its constructor right here. Right, there's its constructor. And if we have all its getters, setters, whatever. And let's take a look at weapon. Class weapon is derived from equipment. Actually, everything can be derived from equipment, but class weapon is derived from equipment. You will notice that we have its constructor and we have its super, right? So get this information from the parent. So in a weapon, these first four, right? That's the parent stuff. That and the super is telling us we're going to get those attributes from the parent, but yet we're going to need damage and strength. That's here. And then we have all our setters, getters, and whatever. Remember, a child can use methods from the parent. And it has its own print methods. The parent has his own print method too, but it has print general weapon. Now let's take a look at melee weapon. Okay, same thing, just a different name. You'll see this many times. What is it? We have the weapon, and now let's take a look at melee weapon. Sorry about that. I was going someplace else. Melee weapon is a child or is derived from weapon. Remember the thing. Melee weapon is derived from weapon. Weapon is derived from equipment. And let's take a look here. There is our constructor of a melee weapon, and it's getting everything from the parent. Now, melee weapons are kind of boring because melee weapons don't have any additional attributes to them, but it's still the same principle. Still the same principle that the child is being derived its stuff from the parent. We're just not adding anything to the child. Then what we got here? Then we have the print melee weapon. Let's take a look at ranged weapons or projectile weapons. Now this is a little bit interesting. Range weapon is derived from parent of weapon. Weapon is derived from its parent of equipment. And there's our super right here. All right. Super says, well, let's get this in line here. Super says derive these things from the parent, technology costs, equipment, technology level equipment costs. But then remember, in a range weapon, we have to include accuracy, range, rate of fire, and number of shots. But what's interesting, or I think is interesting here, is the range weapon and the melee weapon are children of weapons. We see that right here. Weapon is a child of equipment, and we're not doing anything, no redundancy. We're just saying to get this stuff from the parent. And here's our sets and gets and all this other interesting stuff, or what I find is interesting. You will notice that it's calling right here, print general equipment, print range weapon. So it's using methods from the parent. Again, I'm going to keep stressing this. A child can use the methods of a parent. Parent can't use the methods from the child. Child can acquire things from the parent. Parent can't acquire things from the child. So let's go back to our program. Let's go back to main. So in main, what are we going to do here? We're doing an equipment. All of this is equipment. Equipment is something we can carry. We're going to create 30 feet of rope. We're going to create a small shield, We're going to create some cloth armor. And if I go back to Visio, a shield adds just a defense bonus, armor adds a damage resistance to equipment, and then weapons do all the other stuff. So, and then after we created those pieces, parts, the rope, the shield, the armor, we're going to create a melee weapon, just a basic weapon called an axe. And we're going to create a longbow, which has different characters. So all of these objects are going to have attributes based upon their parents. When we get into specific weapons, the melee and the thing, it's going to have its parent information, the weapon, and the weapon is going to have its parent information, equipment. So let's run this. So let's see, 30 feet of rope does this. You'll notice with small shield, we have the tech level, the cost, the weight, and a defense bonus. With cloth armor right here, we have tech level, cost, weight. Everything has a tech level, cost, and weight, and we have a damage resistance. And then we get into a melee axe has tech level, cost, weight. They all have that. That's being acquired from the parent or grandparent. And then the damage it does, the strength that is required. And then we get into longbow, has tech level, cost, weight. It's getting that all the way up from equipment, but then it's getting the weapon information, which is strength, damage and strength. That's getting it from its parent. So let me rephrase this. The actual weapon type, the range weapon, is getting some information from its parent and some information from its grandparent. And then finally, it has its own information, its accuracy, range, rate of fire, and shots. Let's wrap some things up. All right, a lot of stuff was covered in these past two videos. The core, the key is that one class can acquire information from another class. So a child can get information or can use or be derived from a parent class. That reduces redundancy. In the examples I provided, when we had a character versus an animal, we really couldn't do a child-parent relationship because the methods were so different, how things were derived were so different that they were just isolated from each other. But then when we looked at vehicles, and we said, well, all vehicles have these base 10 things. It's only a watercraft and an aircraft that has one thing different or added one thing. So we said, perfect example of a child-parent relationship. So we created a vehicle class, and then we created 3 children classes from them: a ground vehicle, watercraft vehicle, and air vehicle. No redundancy, right? If I did not have inheritance, I would have to create 3 individual classes basically with the exact same information and the same methods. And if I had to make change, you can see how that can get very unwieldy. When we finally deep dove, or we had children of a parent, when we got into equipment, all equipment that we carry had the same attributes, but then the children had different things. So we had base equipment, we had shields, weapons, and armor, and then we had weapons, and there was 2 types of weapons. We had projectile weapons versus melee type weapons, but they all had that same characteristic. And again, it reduced redundancy. That, to me, that's kind of like the really big thing. So these individual classes reduce redundancy, making your code far more efficient and making design characters efficient. And if you begin to start looking at things, I know I use GURPS, but we're not really learning GURPS here. If you begin to look at things, you begin to realize that a lot of things can be brought down into these child-parent type relationships. You can start with an automobile. Well, there's different types of automobiles, but all automobiles in our world have 4 tires, right? Automobiles versus motorcycles, but automobiles all have four tires. So we could have a subclass of different types of, we have sport utility vehicles, we have sport automobiles, we have vans, and each one of those all have the base characteristics of an automobile, but there could be or would be different attributes associated with a sports car and a minivan, right? reduces redundancies. Probably the difference between a sports car and a minivan, probably 95% of them are going to have the same things, wheels, steering wheels, tires, whatever. But then a sports car might have additional things, or the minivan is going to have additional things. I have a minivan. So, like in my minivan, I have a DVD player for the back seat. I don't think you're going to find a DVD player for the back seat. So maybe the class minivan, we have entertainment system. We have an attribute called entertainment system that we would not have in a sports vehicle, a sports car. So you can see how we begin. So I think it's a very interesting topic. I strongly encourage people when they be introduced this, start looking around at things and say, okay, that's really a subclass of another thing. So hope you enjoyed the videos. That being said, let's go and learn something.